over here is snakes and ladders. I do suggest reading the problem description on your own because it's a pretty long one. But this is the board that we are given. So if you notice that it's firstly, it starts from the bottom. So the count starts from the bottom left corner. You go all the way until 6, and then instead of starting from here, it's actually reversed. So 1 to 6 and then 7 to 12. So this goes normally, then this is reversed, normally reversed. So keep that in mind. Now let's start with a question. So we are using BFS over here, which is breadth first search. I start in the classic way, which is you get the size of the board, which is n equals to length of the board. So in this case, in this board, it will be n equals to 6. So then you get the target square. Now the board has n squares. So over here it's stated, return the least number of dice rows required to reach n square. So target will be n and square, which is n times n. That is your target square. Now this is the get position function. This is the whole complicated part of this question. So I'll run you through it line by line. So what this function does is that it gets you the position. So given a square number, where is it located inside this 2D array? So first is row from bottom. So as I said, this starts from the bottom. This is how it is numbered. So let's say you have to find square 14 over here. So how this is calculating where which row from the bottom is square 14 located at. So it's getting the square that you are looking for, which in this case is 14, subtracting 1 and then integer division by n. So 14 minus 1, integer division by 6, and this will give you an answer 2. So if you look, row 0, row 1, row 2, it actually lies in row 2, 14. Now you have to find the column. So not column from the left, right, bottom, top, just your column index. So in this case, it's square minus 1 mod n. So square, you're looking for square 14. Subtract 1 from it, which is 13. Mod n, n is 6 in this case. That will give you answer 1. Row from bottom was 2, column was 1. And we do know it's 0 and 1. It is actually the first column, and that we can then find where 14 lies. Now this was row from bottom, but Python actually starts row indexing from the top and not the bottom. So you have to convert the row to Python indexing. So that means that to calculate this, you are getting the n minus 1, subtracting row from the bottom. So n is your 6 minus 1, which was 5, minus your row from the bottom, which was 2. So that will give you 3. 0, 1, 2, 3, and that is exactly where it lies. So you're just reversing it. If row from the bottom was 2, then row from the top will be the whatever is left over. So this is how you're calculating that. Then you are going to handle the zigzag. So 1 to 6, then 12 to 7, 13 to 18. This is how your labeling was happening. Now, in order to tackle that, what will you do is, if you notice over here, if this is your row from the bottom, this was 0, then this was 2, this was 4. So all the even ones are actually fine. It's the odd ones which are reversed. So 12 to 7, this is row 1, odd number. 24 to 19, again, this one is also your row 3, which is again an odd number. So you notice that it's the odd rows from the bottom which are being reversed. So how will you do that? So you check if your row from the bottom in mod 2 is equal to 1, which means in this case you're confirming if it's an odd number, because this will give you the remainder 1 means it's an odd number. In that case, column equals to n minus 1 minus column, so you're technically reversing all the numbers. So n minus 1, in this case your column was if your column is 0 and your n is 6, then n 6 minus 1 is 5, and 5 minus 0 is again 5. So now your new column index becomes 5. So your 0 column became your 5 column. Similarly, you can do it for other numbers, and your 0 column becomes 5, your 1 will become 4, 2 will become 3, 3 will become 2, 4, 1, and 5, 0. So all numbers that are over here basically jump over here, and the ones which are over here jump over here. And this is how you reverse it. And at the end, you're just going to return the position of row and column. Now we start with our simpler bit, which is BFS. So you start with a queue, which is a double-ended queue, and we are storing the square and the number of moves in there. So if we store 1, 0, it means we are currently on square 1 and we have made 0 moves. Then we have a visited set, which means we have already visited square 1. Then we start at BFS, so while queue is empty, which means as long as there are squares waiting to be explored, we continue. We pop from the queue and we assign it values, variables, square and moves. So this takes the first item from the queue, so square will be 1 and your moves will be 0. If square is equal to target, return moves. Check if we have reached our destination or target, then we just return. And then for dice in range all the way from 1 till 7, so we know that a dice can give 1, 2, 3, 4, 5, 6. So if we are on square 1, we try 1 plus 1. If we are on square 1, we try 1 plus 2, 1 plus 3, 1 plus 4, 5, 6, which is equal to 7. So it's all the way until 7 is what we are going to try. Then you have your next square, which is square plus dice. That's what I said, that the square that you are at is die plus whatever you get on that dice will give you the value of next square. And also over here it's 1 till 7 because your dice only has 6 possible values, 1 plus 1 all the way until 6. That's why it's 7 over here, and the 7 is non-inclusive. Now we make sure that we don't go past the board. So if next square is greater than target, then we continue. And then we find where this next square value that we computed is on our board. So for that we use our get position function, and we assign a row and column, and we pass the next square in the get position function. Then we check if it's a snake or a ladder. So if row column is not equal to -1, a normal square contains -1, which means there's no snake or ladder over here. So if it's not equal to -1, in that case your next square becomes board of row and column. Then if next square is not in visited, then we add it to our visited square, and then we put it in our BFS queue, and we are reaching this next square in one more dice roll, and therefore we are adding moves 1, and that is it.